Okay, minasan, konnichiwa. Zamurai Engineer desu. So I will wait for the sound check confirmation. Please confirm our sound if it is clear enough. Sound test, sound test. So please confirm, sound check, please. Okay, thank you. So therefore, we can start our discussion, and in this video, we will now, for the first time, take a look at the bridge girder framing plans. So what are the necessary details? Take a look at the details, because some of the details might be helpful, and actually it is actually helpful, because we are studying steel design, we are studying reinforced concrete design. Therefore, either way, bridge could be made up of steel or concrete, or combination of both. Therefore, it is helpful, it is necessary, and because of that, the explanation of details here has a direct effect on our design of reinforced concrete and steel design. That's why, please listen. Okay, we already tackled all of the things, the general principle, general concept behind bridge engineering. However, we started to get back for more details on engineering and design level of details, starting from module 5.05. Now we are 5.06. Okay, so what we have to expect: girder framing plans. So for a bridge application, framing plans show identification, geometry, and arrangement of the following. Now, what are those? Girders, number one. Okay, girder is the main support system of a bridge. Okay, cross frames. Okay, different types of supports, like what? Abutments. Okay, piers, bearings. Okay, those are the support components. What else? Field splices. We need to be detailed on these field splices. For example, we will talk about welding, we will talk about butt connection, we will talk about bolt connection. It is very important in our study of steel design. Okay? So how do we connect one a steel component to the other, splicing. Okay, we will splice. So currently we are talking about steel area, net area, gross area. That has something to do with some application like this one. Okay, we need to study the details. What are the details that are necessary as a minimum in order for us to design and analyze a system in a structural manner, okay? Stiffeners or bracing. So these are the things. Specifically, we have five. We have five things that we need to uh, be involved in when we are talking about girder framing plans. Okay. So from time to time, I will look at the comment section if ever you have any question. So I would be able to answer your comments. Okay. So we are now in the next slide. We have girder bridge framing plans, starting with straight girder. So when we have straight girder, we have this particular application, straight girder. So it's very small, almost we cannot see anything. So it is a plan, there are lines, there are dimension. So let us try to enlarge. Let's try to enlarge. Let's try to enlarge. Okay. So can we read? Can we read the details now? Is it readable? For example, this one. Can we read it now? Can you read it? Please, please react if you can read it. Okay. So it is now still small but readable. Okay. Sir, medyo malabo po. So let's try to enlarge it even more. Okay, so what about now? Okay. So it is now clearer than previously. So let us start. Let's start off with the upper left side corner. So let's start here in the upper left side corner. Uh-huh. Okay, so let's start off here. So now you can We can read it now. So we can read what? 200 feet plus and 200 feet and 8.5 inches. So that is the total length here. So we have 52 feet. We have 97 feet. Okay, so we can read it, those things. So now let us give it a description. Okay, let us describe. So first, for example, we have an arrow here that expresses the reference point. Okay, it expresses station A, 281.38 plus 11.24. Okay, so this is a reference point in the earth, specific point in the earth. So it is what? Confirmed, measured, and specified by geodetic engineer. Okay, so we already have the understanding. We already have the surveying subject. So you already finished, passed the surveying subject. So you can understand what do you mean by station A. 28.138 plus 11.24. We know what do we mean by this. Okay, so that is reflected on this specific point. There is a point here, and that is the our specific measurement. Now you will notice from that specific point we can refer to the neighboring dimension here. Okay, the neighboring dimension and the neighboring dimension here. So from that point up to that end, we have what? 9 feet and 3 and 1/8 inches here. 9 feet, 3 and 1/8 inches. Okay, specific, very specific, 9 feet. Okay, from this point to that reference point. Okay. Okay, point 8 or station A. Okay, so and one bay is actually not 9 feet but 10 feet and 10 and 1/8 inches. So from this point to the next one, that is one bay, and you will notice the neighboring bay is the same, and so on. So each bay will have 10 feet and 10 and 1/8 inches. Take note, 10 feet and 10 and 1/8 inches, 10 feet and 10 and 1/8 inches. Okay, so therefore, so 9 feet 3 and 1/8 inches minus this one, the distance of this is actually what? How much this? This is 1 feet 7 inches. Okay, 1 feet and 7 inches. Okay, as you can see here, the distance from this reference point to the first interior bay, no? From first interior bay reference is 1 feet and 7 inches. Okay, then next important thing, that those are the bays. We have what? We have the symbol I here, symbol I. I think this is letter I. Okay, so letter I as a symbol, and we can see the angle here. You can see the angle, and that angle is actually equal to 78 degrees 54 minutes and 19 seconds. Okay, TC. So we already know what do we mean by TC. Okay, PT or TC, those are very important in our surveying to those points. Okay, So 78 degrees, 54 minutes, 19 seconds. Okay, as you can see, they are not parallel. So this line and this line are not parallel. Okay. So another important thing here, we have a component we call jacking stiffener. Typical, meaning if we have the word typical, we can expect to see this again in some other places. That is what we mean by typical. So this jacking stiffener, okay, is also here, jacking stiffener, and also there, jacking stiffener. So they are all jacking stiffener the same, and in almost the same relative position to the B. Okay, and just below the jacking stiffener, we have bearing stiffener, typical. Therefore, we should expect that bearing stiffener are also to be expected in other parts of this. Okay, so this one, bearing stiffener, bearing stiffener, bearing stiffener. Okay, so maybe this one, another bearing stiffener here, bearing stiffener. So jacking stiffener on the right side, bearing stiffener on the left side. So, okay, so jacking stiffener and bearing stiffener, jacking stiffener and bearing stiffener. Okay, so what do we mean by stiffener? So stiffener in our local dialect, we have pampatibay. Okay, pampatibay, no? Or that is the Tagalog word stiffener, pampatigas, no? Stiff. Okay, patigas, pampatigas ng component. Okay, pampatibay yan, no? So brace, okay, no? So specifically, we have this included in our design, in our plan. So okay, so let's continue. We have begin bridge, FFDW and bend. So end bend, that is our one of the main substructure component. Okay, so end bend, that is where the definition of end bend is where the bridge begins, no? And the highway ends. The road ends and the bridge begins. That is the end bend. Okay, so therefore end bend 1, no? So and we have what? Typical of distance from end. So bearing stiffener to jacking stiffener, typical distance is what? 1 foot 3 and 3/8 inches. This one, 1 foot and 3/8. So in the drawing, it is very near. It is almost about 2 millimeter in the drawing right now. But actually, this distance is about this part. That is 1 foot and 3 and 3/8 inches. Okay. It is more than 15 inches, no? 1 foot and 3 and 3/8 is more than 15 inches. So that is very about this length, right? And this one is typical also, but this is what? 6 feet, typical 6 feet. So from the jacking stiffener to this component, 6 feet. Okay, so we have again another typical dimension, 11 feet. 11 feet, so 11 by 11. So we have what? Again, another component. So these are what? We can see there is a line between the jacking stiffener center line and the end or bearing stiffener center line. In the middle, we have end diaphragm, typical at end bend. Okay, so this is typical at end bend. This is the end bend. Okay, this is the end bend. Okay, so begin bridge. Okay, so that is actually the end bend. Okay, so beginning of the bridge. Okay, so this line is the diaphragm. So diaphragm also is one component that gives us uh, a function to brace or to support to make the system stronger. Okay, so diaphragm, but the diaphragm is usually they are in perpendicular with the girder. So where are the girders? This line is the center line of girder. So that is the center line of girder 1. This is the center line of girder 2. This one. This one is the center line of girder 2. This line is only representing the center line of the girder. Okay? So this is the center line for girder number 3. Okay? And girder number 4 and number 5 here. Okay? And so on. Okay? So those are the girder. And since those are the girders, we have the diaphragm, which is what? Perpendicular to that. Perpendicular to the girder. So these are the girder, this is the diaphragm. Okay? The diaphragm supports the girder. Okay? Because the girders may be very long. And if the girders are very long, there is a tendency to what? To buckle. There's a tendency to buckle. Okay? So they are very long. That's why there's a tendency to buckle. And if they buckle, what will happen? Okay? So the bridge will fall. So yesterday, as I am hearing the news, I encountered the news on bridge failure. So I will show you a bridge failure. So let us show you a bridge failure here. It's a picture. And I will search for the picture of that failure of the bridge. And the bridge is in somewhere in Bohol. Okay? Somewhere in Bohol. Okay. This is a bridge. This is the bridge somewhere in Bohol. Okay? There's a bridge somewhere in Bohol, Katigbian, Bohol. So it was damaged. It fell because there is a trap. This is a very large trap. 20 wheeler truck, meaning 20 wheels. It is about 40 tons. 20 wheeler truck, about 40 tons. And as you can see, the bridge is only 20 tons capacity. The bridge is only 20 tons capacity, and the truck has a 40 tons weight in total, including its own weight. Okay, so please give me 1 minute. I will answer something. I will answer. Somebody's calling me. So please write your question or any comment so that I can talk to somebody on the phone. Okay, so okay, somebody asked me for X-ray, so anyway, let's go back to our discussion. So this is how we can expect a bridge to perform. If you overload the bridge, it will fail. It is clearly stated that the bridge capacity is 20 tons, and you try to cross the bridge with a total of 40 tons. So what can you expect? What can you expect? Okay, so please do not follow this type of behavior. Okay, that is a very dangerous behavior. So when you are a driver, you are responsible for your load. Okay, okay. In our country, you can just start up the engine and you are already a driver. That's why many of us are not responsible driver. Okay? So, driving involves this load estimate. You have to estimate your, if you actually need to weigh your truck. There's a weighing scale along the highway. There are weighing scale. Usually by DPW, it's usually by private companies, but you have to pay. If you weigh your truck there, you have to pay. Okay? But that is for safety. Okay? That is for safety. So why you have to trial and error? If the bridge can carry it, it will not fail. If the bridge cannot carry it, it will fall. That is not the correct attitude of a professional driver. Okay? Okay, so that's why we need to understand that if we design a bridge, there is a capacity. Okay? We take note of the live load, the dead load, the environmental load. We even are taking note of the accidental load. We are even thinking of that. However, if you breach those maximum, the bridge will of course fail. That is the real life example. Okay? So, there is enough safety factor. There is enough safety factor for 20 tons bridge. If that is specified as 20 tons, it can carry about 3 or about 30 tons. But that is the critical point. But if you try to do it up to 40 tons, obviously it cannot resist 40 tons. So maybe 30 tons can resist the load because of the safety factor. There is a safety factor that we are using. We know the description, how we use the safety factor in what? ASD design. We already know. How much is the safety factor in ASD? 1.67, sometimes 2. Okay, 1.67 and 2. Okay, we already taken note of that on our steel design. Okay, what about LRFD? What are the reduction factor in LRFD? I already shown you 0.9, 0.75 reduction factor. Take note of those things. So I already shown those things. I already explained those things. Okay. So what are the potential load of the bridge? Is it more on dead load? Is it more on live load? Okay. So we already talk about those things. Okay. We already true. At this point, you already have an idea. Okay. So we will take note of these points, and they are what? The diaphragm spacing. Okay. The diaphragm spacing. Okay. These are the main points of support. However, in between we have this one, this one, this one, this one. So they are this one, this one. You will notice from this point to this point, this point to this point, we have 11, 11. So we can say that from this point to this point, this is 22 feet. This is 22 feet and also 22 feet, 22 feet, 22 feet. So you can estimate that okay, you can just count the 22 feet. Okay, so therefore 1, 2, 3, 4. Okay, so it is more than 4 times 22, that is 88. So this is more than 88 from this point to this point, and we can confirm because the actual measurement is 97. That is more than 88 as I estimated it. So we can estimate. So from this point to this point, 2, 3, 4. 4 times 22, 88. So we have what? Excess. So it is more than 88. That's why it is 97 in actual. Okay? So let us move on to the next side. So we have the next side. So again, as you can see, girder 1 to 4 and 5 here. Next, of course, is girder number 5. So this is now what we call intermediate diaphragm. So they are all diaphragms, but the diaphragms at the end is what we call end diaphragm. The diaphragm inside the end points are what we call intermediate diaphragm. So diaphragm, what do you mean by diaphragm? I will show you. What do you mean by diaphragm? So I will again search for my picture of diaphragm. So I will search for the picture of diaphragm. So diaphragm. Okay, we can show you. What do you mean by diaphragm? Okay, we have here. Okay, so in in your screen you can see interior girder. Okay, you see exterior girder. So this is what girder looks like in actual. So this is the deck. This is the deck, and from this point to this point, that is the deck overhang. This is also a deck, decking. Those gray portion, this one, similar color, they are deck, the same color as the concrete. Okay? So concrete colored portion, they are decking. So they are concrete, reinforced concrete. Okay, and the girder is steel, W type beam. Okay, this is what we call exterior girder because this is the outside facing. It is facing outside. It faces the outer part of the bridge. So that is what we call exterior girder. Those girder inside is what we call interior girder. And since this is the first one, we call this is first interior girder. Do you follow? Do you follow the difference? They are all girders. How many girders can we see? 1, 2, 3, 4, and 5. Okay? There are 5 girders here. Okay? Okay, and I think you cannot see my picture. My pointer. Cannot see my pointer, but you can see the first interior girder, and therefore the neighboring to the left side of that is the second interior girder. Okay, as compared to the exterior girder. Okay, so we have the deck overhang arrow here. Okay, where is the diaphragm? These are the diaphragm. This one. These are the diaphragm. These are the diaphragm. You cannot see my pointer. Okay. How can I make you see my pointer? The diaphragm are those in this picture. The diaphragms are the one that connects girder to girder. They are in between the girders. Okay, they look like trusses. Okay, they look like trusses in this diagram. They are the diaphragms. So how many diaphragms are there? As we can see, 1, 2, 3, 4. So there are 4 lines of diaphragms here. I will look for another picture, maybe much better picture to show you diaphragm. I will look for another one. Okay, this one. Maybe this is better. Okay. 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 This is again the what? The picture of a bridge when you are looking from below. You are looking up. You are below the bridge and you are looking up. Okay. So you have girders and diaphragm. You cannot see the actual diaphragm here, but you can see the form and pulse work for the diaphragm. You can see the form works. Okay. So the form works of the diaphragm you can see as wood. Those wooden parts are the form works for the diaphragm. Okay. So most possibly the diaphragm here is made up of concrete rather than steel because there are form works. Okay. Do you follow? You follow? So diaphragms could be reinforced concrete and could be steel. So the long lines of beams here are W-type beams and they are called girders. Okay, they are girders. Okay, maybe we can still find another picture for you to be able to okay, so maybe this is better. So you have a girder. As you can see, you have the red arrows. The red arrows describe the girder depth. Okay, girder depth, the red arrows. And also another red arrow describing unbraced length. Okay, So D, capital letter D, and capital letter B. Because small letter D, we know that that is the depth of the beam. Okay, small letter B, that is the what? The width of the beam. But capital letter, we say that is unbraced length, and capital letter D, girder depth. Okay, now as you can see on the unbraced length, the arrows are pointing at the diaphragms. Okay, the distance of diaphragm, that is the distance of unbraced length. Okay, so those component that are being touched by the arrow showing unbraced length, they are the components called diaphragm. Are we clear? Are we clear? Do you follow? Now you can understand what do we mean by diaphragm. So those components that are being touched by the arrows of unbraced length, okay, distance, okay, so those are the diaphragm. Okay, so okay, let's continue with our so those are what we can expect on this diaphragm, the typical diaphragm. So it means from this point, okay, from this point to this point, that is the diaphragm. So the diaphragm supports and stiffens the girder to prevent girder from torsion, okay, or buckling, torsional buckling, or local buckling, or global buckling. That is the purpose of this diaphragm. So from this point to this point, that is our diaphragm. Okay. What else we can describe here? So 22, 4 is spacing at 22, so 88. So we are correct. That is what? From this point to this point. If you count 1, 2, 3, 4, exactly 4. That's why it is 88. 22 times 4, 88. Okay? So that's why we know that the spacing of diaphragm is actually 22. That is the spacing. So meaning this is a center of the diaphragm. So 22 diaphragm to diaphragm. This is a center. Okay. What else? So let us proceed to the lower portion. Lower portion, we have intermediate stiffener. Those are not diaphragm, but they are stiffener. Okay. Look at there is a beam. The beam looks like this. So we have a stiffener here from this point to that point, and they are welded. They are usually welded because they are stiffener. Okay, they are lateral stiffener like that. So the W type beam looks like this. Okay, a W type beam looks like double C channel, di ba? Okay, so double C channel. So we can make a flat bar that could be welded like this at exactly this location. So you can weld an intermediate stiffener measured what? The span, the distance of stiffener to stiffener is 22. Another 22 stiffener, another 22 and so on. So meaning at the middle of diaphragm, we have to make a stiffener. They are not diaphragm, but they are stiffener. It stiffens the web of the W-type beam. Okay? So, are we following? Do we follow? We know what is W-type. We know what is beam. We know what to expect about flans and web. So, we are stiffening the web by putting a plate of metal that way. Okay? Okay, so this is the web of the W-type beam. It's very small, very thin, so we want to stiffen. We want to make it stronger. That's why we put a intermediate stiffener. Okay. Next, what else can we see? Field splice type 1. Okay. Field splice. So these are the splicing. So there is a beam W-type girder, and we have to splice it, meaning we have to connect to the next unit of beam. W-type connect it because we need longer bridge. Okay, so from this point to this point, from this point to this point, 88 feet. So we cannot have infinite length of beam. We cannot produce infinite length of beam. That's why we have to splice. Splice meaning this is joint. Okay, it is one piece of beam ends and another piece begins, and they have to be joined together. That is what we mean by splice. And in this splicing, you can notice we have two plates. So we have splicing here like this, and we have two plates in between. So that is what we mean by this symbol. Okay, so that is the field splice type 1. Okay, so going to the next side, to the other side, so we have that optional field splice type 1. So we have field splice type and we have optional. Okay, so there are 5 girders. Okay, now see the overall width. This is the overall width of the bridge from girder 1 to 5. So we cannot see if there is an overhang. We do not know if there is an overhang. We can see it on the other plan view. So it depends on the plan view. Now we are just looking at the girder. We are just looking at the girder details. That's why we don't know the other types. Okay, so let us move on. Any question on this slide? Can we now move on to the next? Okay. So let's move on from straight girders. So those are the straight girders. Because bridges, if they are very long, sometimes they may need curvature or curving of path. The path is curvature or curve. It's not a straight line. So these are the straight line parts of the bridge. What about those parts that are not straight? For example, so the same that we talk about, but now we have what? Girder, cross frame, we have intermediate stiffener, and we have bearing stiffener, we have field splice, and
Nakuha ko lang, tingnan mo na lang.
Okay, thank you. So, so all of which I already mentioned and I already discussed. Aside from cross frame. Cross frame is actually the type of the diaphragm that we use. The diaphragm that we use here is cross frame type because it looks like trusses. Take note, it looks like trusses. That is what we call cross frame. Okay? That is cross frame. From this point to this point. Those are actually diaphragm, but look here, intermediate diaphragm, and then it is called cross frame because the type of diaphragm is cross frame in this particular example. I already shown you the type of diaphragm that is reinforced concrete. Okay? So that is not cross frame, that is reinforced concrete diaphragm. Okay? Okay? So very clear. So we are all clear about how much detail we need to input to incorporate in our plans. Okay, if I assigned you to give me a bridge plan, that is what we need to show. That is the detail. That is the details that we need to show. Okay, before I forget, assignment. Okay, assignment. We will do this in real world. Okay. Choose one type of bridge. Either it is a pedestrian bridge, either it is a highway bridge, or either it is an ordinary bridge. Choose one bridge. Particularly those bridges that are near to you, and particularly those bridges that you can take a picture of. Your assignment is take a picture of that bridge in so many angles, okay, so that you can show these parts. You have to show these parts. You have to show the girder, you have to show the stiffener, you have to show the diaphragm, okay, you have to show the bearing. Most of the parts, you already know what are the parts of substructure. You already know what is the part of the superstructure. Of course, we cannot take a picture of those parts underneath the soil, but up to the what? Up to the substructure. So take a picture. For example, in Bikutan, you have what? A skyway. That is a bridge. That is a type of a bridge. Okay? Skyway. So you can take a picture. I don't need you to go to the skyway and walk over the skyway. That is very dangerous. Okay? What I am asking you to do is just take a picture as clear as possible wherein you can locate, make an arrow and show me girder, a diaphragm, what else? Bearing, what else? End bend. Okay? Oh, show me the end bend using those pictures. Show me the what? Deck. Show me the what? The overhang. Showing the barrier. Show me the barrier. So those components. Okay? Okay, using arrows. Okay, using arrows. Okay, I need to check using arrows. So nearby or within Taguig City. Near or within Taguig City. You don't need to go to the provinces. I don't want to hear somebody asking parents going to provinces to take a picture of a bridge. Okay? Ibig sabihin yan, in our local dialect, gusto mo lang maglayas, no? Okay? So, wag nyo nang idahilan yung subject natin para maglayas ka. There are plenty of bridges inside our city. and take a picture from a safe distance. Okay? You have to take picture from a safe distance. It's very clear. The instruction from a safe distance. Okay? So that you can show me and you can have the actual experience. Okay? You can inspect one by one the different parts. Okay? That is how you have to deal with your job when you are a site engineer. Okay? You have actually site engineer have to measure the distances, measure the dimension of those components, measure the location, the position. Those are the things. And how can he do it? With respect to this measurement. This is his basis. So if the actual measurement is not equal to this one, there's something wrong. So therefore, this is very important. Okay. Now let's go to the next slide. So we have the same bridge under construction. Okay, same bridge. So this is what we call end bend. This is end bend. This is the location of end bend. End bend, another end bend. So end bend 1, end bend 2. Okay, so it could clearly show the girders. This clearly shows the girders. Okay, it clearly shows the girders here. It clearly shows the girders here. Okay, and because of the shadow, I can surmise that these are the diaphragms because of the shadow. I can surmise it, and the diaphragm is cross frame type diaphragm here. So these are the diaphragm. So end diaphragm, interior diaphragm 1, 2, 3, 4, 5, 6, 7. So these are the diaphragm. So there must be a diaphragm here. Currently there is none. So there must be a diaphragm here. Currently it is being constructed currently. So there is a diaphragm here. So similarly on the other side, corresponding diaphragms are there. Okay. Okay, so this is the point where the highway ends and where the bridge begins. Okay, take note. We still call this a bridge even if there is no water under it. Bridges are not only for water. Take note of the definition of the bridge. We already defined what do we mean by bridge. We have to connect this topology. This higher topology is disturbed by the lowering of the topology here. That's why we need a bridge in order to connect it effectively. Okay? Or maybe in this case, there are highways underneath rather than water underneath the bridge. There are highways underneath the bridge. Okay? So that is another function of the bridge. That's why we call skyway. That is not a skyway. Actually, that is a bridge. Okay? Skyway is a bridge. Okay? Similar to this one. Because there are roads underneath the skyway. There are roads. So it is similar to this. Okay? So girders, this is now the exterior girder, and this one is interior girder, the first interior girder, the second interior girder. Okay? So can we clarify it now? So those are what we mean by this. Okay, next. Curved girders. So what we already shown you are the pictures, the details, the references with respect to straight girders. How about curved girders? Well, it is possible. So, for example, there is an skyway along expressway, above the expressway, the South Expressway, and going to the airport. You will notice that will include curved girders because from the South Expressway going to the airport, it will turn. So when you are from Muntinlupa going to Makati and you have to turn to go to the airport, you have to turn to the left. Turn left. Okay? Okay? Do you follow? Do you follow? So, therefore, it is also possible for us to have curved girders. So, can we look at the? So we have to go to the next. To the framing plan. Let us enlarge this. Let us enlarge. Let us enlarge so that we can read. So what we can read? Arc length along, okay, DF fly, okay. So that is what else? What else? Oh, asterisk is equal to arc length. So that is legend. This is legend. What do you mean by circle with cross? Radial dimension. What do you mean by cross? Measured perpendicular to bend control line. Okay? Or end bend fill face. Okay. So control line. That is a technical term that we learned from surveying. So review your surveying because surveying is the prerequisite of the subject. Okay? So what are the important things that we can see here? We can refer to the next slide. Okay? So we have what? Girder again. So girder are curvature, curving girders. Cross frame again. Field splice. So field splice. Those are the point wherein we can connect one piece of girder to the other piece of girder. Okay? Intermediate stiffeners. We already know about those things. So the same level of details with the straight. The difference is this is curvature, and because this is curvature, we have angles. We have angles here. So can we go back? So let's take a look at the angles. Okay, we have dimension. We must have angles. Okay. So bend control line. So the bend control line, we can expect angles here. So number 6, we have angles here. Here. We have the measurement of angles. Okay. I will take off my camera first so that you can see. Okay. So here. So we have an angle here which is called number 6. Angle number 6. Okay. We have another angle here which is called number 5. Another angle there which is called number 4. So that is the only difference between curve and straight. So if we are using curve bridge, we have to expect curve girders. And curve girders plan, framing plan has to have an angle. So there are control lines here. Control bent line number 3 and control bent line. So these are control lines wherein we can show our angles. Okay, we have angles. Okay, we have angle. And therefore, if you are a engineering inspector visiting a site to evaluate the construction site, so you have to have a tool that could measure angle. You have to have a tool that could measure angle. Measure this angle, and compare it to the value. There are values. The values of angles are tabulated. 1, 2, 3, 4, 5, and 6. So we can find out the table of values inside the plan, inside the bridge plan. Okay, and then there are different values of angles here. That's why we can check and we can verify it in actual construction. Okay, so that is the only difference with respect to the details when we are confronted by curved bridge or curved girders. Next. Okay, what is this? This is girder bridge framing plan. So I girder bridge framing plan. So again, generic term I girder. Okay. So instead of saying W, we say I girder. Generic word. Okay. So that it could be understood by layman's or the laborers or the workers. However, inside the plans, there is no mention of I girders. It is only girder, and there is a tabulated specification W type or S type. Okay, there is no mention of I girder. Take note. Okay. Oh, this is an actual picture. Okay. Of curved girders. Okay. So we can show you exterior girder, first interior girder, second interior girder, or middle interior girder, or the first interior girder, and another edge. So there are two exterior girders, one for each side, 1 and 2, both sides. What we call exterior girders. Okay. So we have what? They are just making the formworks and false work. So this wooden diagonal wood support, they are false work. This part, wooden parts are formworks, meaning this bridge will have an overhang, and the type is concrete, reinforced concrete overhang. Okay? Do we follow? And you'll notice the column is one column and pier. One column and pier type of support, which is in the form of what? Reinforced concrete. The material, reinforced concrete material. Girders, diaphragms, bracing, intermediate stiffeners are in steel material. So steel design. So steel design, RC design, reinforced concrete design. Okay? So usually combination in actual construction. Okay? We cannot expect 100% pure steel, 100% pure concrete. So, mostly combination. Okay? Combination. Particularly when we are talking of bridge. Okay? Like this. So, next, let us move on to the next slide. So, radial normal supports. Okay, so we can talk about it. So we have what? Arc length along the same. So the same what? Type of, the same type of legend. You can see rectangle. You can see the rectangle. Can you see the rectangle here? The rectangle and equal to field splice type. So they are the field splice number. So the number is 1, so that is field splice number 1. 2, when field splice number 2. Or in this case, we have EBAA. Okay? So we have a specific type of splicing. So how it is connected? Type A connection. How can you determine the type A connection? There is details in the framing plan. There is details. We can take a look. The details for A splicing, details for B splicing, details for E splicing, details for D splicing, and so on. It must be included in the drawing, in the plans. Okay, those are ports. So, what are the important things? So, degrees. Okay, degrees, girder, support. Oh, this is the support line. This is what we call support, but at the same time, we are using the support as control lines. Control lines. Meaning there is a support for the bridge at this point, at this line. Okay? Cross frame, we know that already. We know the girder is curved and 90 degrees usually at this point. Okay? Okay. So I already explained this. So there is no additional information. I already explained this. So if ever you need more explanation, you can point it out right now so that I could react and I could answer if you have any question. Next. Okay, so now these are the components. Okay. So we have the actual picture, okay, of the curve and the straight girders, okay, straight girder, curved girders, and another perspective, okay, partially finished. We have the concrete pier and pier cap. So pier and pier cap. So we have curved girders. Okay. So in this case, there are 4. So in this case, there are 5 girders. Okay. So in this case, there are 4 girders. 4 girders. So this is going in one direction, going in the opposite direction. So that is how it works. It is very similar to our skyway. It is very similar to our skyway. Okay, next. Skewed supports. Okay, what do we mean by skewed supports? Well, what are the important things to know? Skewed support. We have table here, and we have what? Legend. So always take a look at the table and legend. What do you need to know? So first, legend. Notes. Girder spacing measured along centerline bearing. Okay, so we already know how to position or to install the bearing, okay, because we have this information. Number 2, all dimensions are measured along girder unless otherwise noted. Okay, so that is what understanding between the designer and the construction engineer. Okay. Number 3, for girder elevation and structural steel notes, see steel girder sheet. Okay, so how to put it up, at what elevation? So there is a steel girder sheet. Okay, legend. So again, this is the indicator of diaphragm type 1, type 2, and type 3 using the rectangle with numeral values of 1, 2, and 3 respectively. Okay, diaphragms not indicated with the symbol are type 4. So if the diaphragms don't have any symbol, they are type 4. Okay, so this one indicates field splice type 1 and this next one indicates field splice type 2. Then this indicates DrAP tabs. Okay, what about the table? So this is more of the details, the measurement, the dimension. Okay, on the table we have what? Girder 1, 2, 3, 4. Girder radius. So that is what I mean by detailed information. We do not only have the details for radius, but also the angle. So polar coordinates is used because it is useful, because the girder is curved in this specific drawing. 1, 2, 3, 4. TC. Okay, TC. So angle at end bent number 2, we have another values. Take note, they are not the same. They are not the same values. Okay, actual. These are actual values from the plan, and we need to measure it in real work. Okay, check it in real work. I already explained the parts ABC. So we have those those B or those section A, section B, section C. So those are the measurement, the dimensions. So in our case, this particular, so we have here B, C. Okay, so these are the dimension, and we have A. So therefore, the measurement from this point, from this line, from this center line to this center line, that is B. And from this center line to this, that is C. And from this line to that is A. Okay? So, meaning to say, from this point to this point, C, from this point to this point, B. Therefore, if you add A plus C, that should be equivalent to A. From this figure. Okay, let us do that. So, for example, here, B is 32, C is 119. So, 119 plus 32, that is 151. So, that is 151. So, if you add B plus C, it is equal to A. So, if you, this one, it is equal to A. So, the answer is 151 feet and 4 and 3/16 inches. 4 and 3/16 inches. Okay? So, that is the summary. We tabulated summary for checking. We will use this later on in the site. Okay? Now, from that figure, what are important things to know? Not 90 degrees. Important. Support. We have the support, but that is not 90 degrees. Usually 90 degrees. So girder, you have the girder and cross frame. Okay? So those are important things to know. This one, this one. They indicated the angles. Okay? And with that, we have the following. We have the following pictures. Okay? So there are more girders in this picture. So 1, 2, 3, 4, 5, 6, 7. 7 girders in this picture. Okay? So this is what we call box girder. This is what we call box girder. So there are what here? There are cross frame here. Cross frame in between the box girder. Okay? So it looks like one girder, another girder, and with lateral bracing or diaphragm. Okay? That is what we mean by that. So diaphragm to diaphragm, 22 feet. 22 feet. Diaphragm to diaphragm. So 22 feet is about what? 22 feet is about 6 meters. It is about 6 meters. So this bridge is very big. This bridge is very big. Okay? Okay, this bridge is very big. Very small in picture, but in actual very big. Take note of the very small human being here. Take note of very small human being here. Here, there is a picture of human being here. The probably the supervisor supervising the crane operator. Okay? So there is a supervisor supervising the crane operator on what to do, how to move this piece. Okay? Also here, take note of a very big truck. Looks like very small component. Okay? This is a very big truck. This is a very big truck that looks like very small component. Meaning to say this bridge is huge. This bridge is so large. Okay? Okay? Parallel girders. What do we need to know? For example, we have 7 girders as I counted. As I counted out here, there are 7 girders. Okay? So 1, 2, 3, 4, 5, 6, 7 girders. What do you need to know? Girders must be really parallel because we have to measure angle. Parallel meaning they have the same angle with respect to our earth orientation. Okay? With reference to some particular we have a reference line actually as shown you on the first few pages. The reference we have station A, for example, something plus something, right? That is our reference line. We have the direction of stationing. So these are the stationing orientation that we can use as reference line or reference point when we are going through the actual positioning or locating the girder. Okay, so very important here. The direction of stationing. Okay, so meaning we need reference point. That's why we need stationing. We are going to define points on the earth surface. We are using measurement tools, stadia or the most the most modern type. Okay, so we have what high-tech tools and equipment for that matter for measuring. Okay, but these are being done by geodetic engineers. Okay? So we just need to take down all the readings, all the measurement, and also we can confirm to the geodetic engineer. Okay, we have to coordinate the geodetic engineer in order for us to be able to use their reference point and lines. There are no additional details. That is the only thing that we need to consider. So we have what? Okay, station 4030 plus 78.16. So that is what we mean. Very specific point in the earth. Okay, with reference to some known points. Okay, the direction of stationing and so on. So we have parallel girders again. So these are the diaphragm. These are the diaphragm. These are the cross frame diaphragm. So we have bracing. We can also call it as diaphragm, but they are not cross frame. Okay, solid plate, or maybe this is. I think this is just solid plate and not. This is not W or S type. This is just a solid plate, or maybe a box box type of what built up frame. So box type built up frame. So I cannot see right now. So we have what diaphragm details, and we have more details on this, and we can find out what is this. It is solid or box type built up frame and so on. Okay, so these are the what the girders. How many girders? 1, 2, 3, 4, 5, 6, 7, 8. So here there are 8 girders. This particular picture. How many girders here? 1, 2, 3, 4, 5, 6, 7. 7 girders here. Here. 1, 2, 3, 4, 5, 6, and 7. 7 girders. Okay? But now we have what? Multi-column. Okay? Multi-column and 1 pier cup. We have 1 column and 1 pier cup. We have multi-column here. Okay? So, variable spacing girder. So the spacing is variable. We have to express it in real values. We cannot use the word typical. So we cannot use the word typical because they have different spacing. So let's take a look how much details are necessary. Now we are just looking at the additional details because we already talk about one by one the details of this. Okay, we already talk about it one by one on the first few slides. So we are just looking at the additional details. For example, this one. Okay, again we already talk about this specific reference point pair number 2. Okay, specific reference point and bend number 1. This station. Okay, so we have these girders. Okay, so there are so many girders, but it only shows 4 of them. No? So how many girders are here? 9. There are 9 actual girders here. 9 actual girders, but it only shows you 4. Okay? Just to show that the spacing of girder are not constant. They are variable spacing. Take a look. They are not parallel. Okay? So the spacing are not the same. And that is the only detail that we need to know. Okay? Okay? What are these? I don't know what we mean by this. What do we mean by this? This is the girder orientation, and you can see the distance here is not the same as the distance here. The spacing here are not the same here and there. So it is not constant. It is variable spacing. Some of the girders, they have constant spacing like this one. 1, 2, 3. 1, 2, 3. But here we don't have constant spacing. We have a variable spacing here. This is just representation of this green here. The same representation. Okay. So actually you can what? You can put it there. Oh, that is the exact representation, right? So that is the exact representation of that component. Okay. So next slide, we have variable spacing girder, as you can see here. The shape is not parallel. Okay, this exterior girder is not straight. This middle girder is straight. Another exterior girder is not straight. So it looks like going bigger at the middle of the bridge. At this portion of the bridge, it is bigger. At this portion, it is bigger. Okay? Variable spacing girder. Bifurcated girders. Okay. So this word alone, I do not understand. What do you mean by bifurcated? So let's take a look what bifurcated means. So span lengths, beam, B34, 35, 36, 37. So several beam names. Okay. So we have span 4, span 5A, span 6A. Okay. So this is for variable. Okay. So I am searching for the word bifurcated. What do you mean by bifurcated? Okay, bifurcated means magkahiwalay. Okay? Bifurcated. So, hindi sila magkakabit sa isang unit, no? So, bifurcated. So, how do we say bifurcated?
Bifurcated.
So, the correct way is bifurcated. Okay? The correct way to say this is bifurcated. So, they are not connected to one another. That is what they mean by bifurcated. Okay. So, the details must reflect that these girders are bifurcated. They are not connected to one another. So, in picture, bifurcated. Okay. Okay, this one. So, this part of the bridge is going here. The part of the bridge is going there. So, it what? It resembles Y. Symbols Y. So, bifurcated. That is what they mean by bifurcated. This is the first time I read bifurcated girder. In our country, I don't know, we have bifurcated bridge. So maybe we have bifurcated girders, but I still have to read for the first time local bridge plan. Okay, that shows bifurcated. So bifurcated. So one is going in this direction, another is going in this direction. So bifurcated. Again, so this is the part. So this is the part wherein the bridge will separate themselves. So you'll notice two sets of bridge. From one bridge, it will become two. This is one set and another set. This is unicolumn, one column. This is multi-column bridge. Multi-column bridge. Okay, one column. This is the point wherein they separate from one another. So they separate, going to one direction and going to other direction. Okay? They are separated. So this is the critical point details. Okay? So how it would be connected, how it would be located, how it would be positioned. So these are the details. So let us look on that details. So let us make it larger. Let's enlarge it. So there are plenty of reference points. Okay, so that we can define those points and initiate the separation of the direction, okay, of the bridge. Okay, so we have these things connecting this one to this one, and then it is this beam is starting from only this point, but this beam is starting long way before. Okay, so let's look at the details here. Just like what I've said, it is very important to know that this bridge, this beam, this girder only started at this point. Okay, while the neighboring beam here, the neighboring girder started long way. Okay, started long way, but this girder just started here. Okay. That's actually what I just observed on the previous slide. So it is the critical observation. That is the critical observation. Okay? So that is what we call transfer beam. This is the transfer beam. The transfer beam is where we started supporting this new girder. Okay? This is the new girder. We need to start it here. So that is transfer beam. Okay? Okay, understood? Another technical term. Transfer beam. Okay? So we have cross frames on bifurcated bridge. Excuse. Cross frame. So let me have a second. Okay. So if you have any question, this is the time to type in your comments and questions. Give me a second. Hey. So we have this specific area. So enlarge here. We have enlarged that section. What can we see? What is? So there is no transfer beam here. No? There's no transfer beam. Oh, there is a transfer beam. There is a transfer beam here. Here. This is the transfer beam. This is the transfer beam. This is the beam that supports the starting of a new girder. This is a new girder. This is the end point of the girder. Started here, which is being supported by this transfer beam. This is the transfer beam. Are we clear? Are we clear? Here, this is a transfer beam. This is a girder that only started at this point. This girder only started at this point. This girder is supported by this transfer beam, and this transfer beam are supported by these neighboring girders. Do you follow? Do you follow the load path? That is the load path. Okay. So contiguous cross frame. Contiguous cross frame, that means continuous. In our local dialect, contiguous means magkakatabi. Magkakatabi sila. Contiguous. Magkakatabi. So, cross frames. So, contiguous cross frames. So, magkakatabi. Okay? Cross frames. So, they are showing us details. Okay? So, I already explained this. This part. Okay? So we need just to show you the pictures. Okay. So contiguous cross frame. So these are the contiguous cross frame. Okay. So here, contiguous cross frame. Only two contiguous cross frame. We will add another one as soon as the component arrives, like this. The component is arriving right now by using crane. Okay, so like that. Those are the here all of the cross frames that I mentioned in this plane. They are contiguous cross frames. After that, we have what we call staggered cross frames. So contiguous meaning magkakatabi. Staggered. So they are not on the same line. That is what we mean by staggered. Take note, we already discussed staggered holes, and they are not on the same line. So staggered frames, they are not on the same line. They are on their own lines. They have their own lines. Okay, so like this, staggered frames. So this one, another one here. Staggered, they are not on the same line. Another here, another one here, another one. So they are similar to staggered holes, staggered frames. Okay. So let us show you. Those are the frames that are staggered. Okay. Okay. So any question? So very clear. It is very clear. So we have staggered cross frames here. They are not cross frames actually here in this. They are not cross frames. There are no cross. They are staggered frames, but they are not cross frames. There is no cross. So it is a miss. They are staggered frames. So typo error. Okay. These are not cross frames. Okay. They are made up of maybe solid plate or box plate, built up plate. Okay. They are not cross type. Okay. Take a look at the plans. Take a look at the plans. There are so many pins. Okay. There are so many pins. Why? We will connect those pins to the reinforcement of the concrete decking. Okay? Okay? In our local dialect, abang na yan, nakaabang na. Abang yan para pag nilagyan natin ng reinforcement bars, dyan natin i-connect. And ipapalaman na rin natin yan sa concrete. Okay? So that is why we have this too many pins. Okay? There are protruding pins on the plans of the girders. Okay? Take note of how we can connect the girder to the decking. That is one way of connecting it. Okay? So lateral bracing. So we can use lateral bracing. Which one are those? So that is the lateral bracing that we incorporated. So lateral bracing. We are going to design lateral bracing in steel design, and take a look. Okay, we have cross frame. That's why the lateral bracing is like this. Usually the lateral bracing is vertical or horizontal, but here, since we have cross frame to take care of the vertical lines here, we can do the lateral bracing like this. But still, we call that lateral bracing. Why? Why we are calling that lateral bracing? Because it supports, it stiffens the girder. The girder is the one we need to make stronger. That's why we add additional lateral bracing. Okay? That is the purpose of this. Okay? So there is no additional details. So let's move on to the next. Let's move on to the next. And that is our picture. This is our picture. What is this? Lateral bracing. So as you can see there are lateral bracing there. Okay? And in actual, this is the lateral bracing. And here, the lateral bracing is cross frame. So lateral cross bracing. Okay? So we have cross frame here. The bracing is cross. Okay. So actually, we are bracing this, we are stiffening, making it stronger. This girder and this girder. That's why we have here this lateral. So there are no lateral bracing interior to the bridge. The lateral bracing are on the exterior girders. Okay, here, exterior. Okay. And actually, this is the last slide. Any question? Any question? So I will wait for how much? For your question, about 30 seconds. For your question, clarification, so on. So let's wait. And while we are waiting, let us run down on the summary of this whole document. So this video, we are able to explain, discuss to you everything about girder framing plans. Okay, we talk about in details what are the important things to know. Okay, what do you need to understand? So we are having that in our discussion just now. So while I am waiting for your questions, I will run down on these slides. Okay. So we started framing plans that would show 5 different things. So what are the 5 different things that we were shown? We have the details of those girders, cross frames, supports, field splices, and stiffeners. Every one of these, we already have the detailed discussion and explanation. What do we mean by support? Abutments, piers, bearings. Okay. So, we shown you everything about this. Framing plans of straight girders, curved girders, radial support, normal support, and skewed support. Okay. Okay. Skewed support meaning the orientation of the pier cap is not perpendicular to the bridge direction. That is what we mean by skewed support. Okay. So skewed support in actual picture, parallel girders, we have the picture, variable spacing of girders. Okay. And we have bifurcated girders. So bifurcated, we have transfer beam. Okay. If we have transfer beam, we have bifurcated girders. Or we have a beam that would start newly started beams. Okay. So bifurcated girders, contiguous, so contiguous frames, and we have staggered frames, and we also have lateral bracing. Everything we have just talked about belong to the 5 classification of details that we need to understand, we need to draw, we need to submit when we are dealing with our bridge framing plan. That is what we call bridge framing plan. So that's all. So shout out. Thank you. Pwede makuha yung PowerPoint, sir, to review more. So that is not possible because I would like you to view the lecture video. Okay? Para yumaman ako sa lecture video. Baka ma-misinterpret, ha? Baka ma-misinterpret. Okay? So to review more, meron naman tayong lecture video sa channel. So baka lang ma-misinterpret, sabihin Dr. Z don't want to share it in the PowerPoint format because Dr. Z want to get rich due to YouTube channel. Okay? So I am not, the YouTube channel is monetized, but I am not earning anything from it. Okay? Okay? So, baka ma-misinterpret. Okay? So, you need, that is the reason why I am posting it, why I am doing it live and in YouTube, because it is automatically posted. You can take a look at it anytime. That is for free. Okay. Since there are no questions, again, this is your professor, Dr. AP, always preaching engineering for nation building.